third lecture in our current topic, that is laws of motion. So here today we will discuss about what? Uniform and non-uniform, yes, linear motion. So let's first of all we know what do you mean by uniform and what do you mean by non-uniform. Okay, so here uniform means what? Yes,
if an object covers equal distance in equal time in interval, then it is in uniform.
that is uniform motion. And non-uniform motion means what? Yes,
If an object covers unequal distance in equal time intervals, then it is in the non-uniform.
okay. In a simple way we can say, suppose me and my friend start walking from my house to our school, okay, but I'm used to go, the speed is what? 10 kilometer per hour, okay, and my friend used to go 15 kilometer per hour, okay. So definitely he will reach soon, okay. But every day if we walk with that constant speed, it means what? At that time our motion is what? Uniform motion. Our motion is what? Uniform with ourselves, not between each other. Like this fan, the speed of fan on a first step, the rotation per second is equal, that is called uniform circular motion. But we are talking about linear motion, means what? A two object or two person walking on the road with a constant speed, that is what? Uniform linear motion. Or a two person or two object walking or moving on the road with different speed, that is what? Non-uniform linear motion. What happened?
Nothing.
You want to pillow,
No.
so you want to go to sleep,
No.
so why are you doing like that? Okay, leave it. Next, linear means what? In a straightforward, okay. So very simple formula for what? Finding the linear. It may be the linear place, linear velocity, linear momentum. Linear is equals to what? Yes, final minus,
Initial.
yes, final minus initial, that is what? Linear. It's very simple. If you want to check the displacement of object, if you want to check the velocity of object, then definitely you use this formula, that is what? Final minus initial. Again, if you want to calculate the linear temperature of water after some time, if you have a water beaker in your before putting that water on the stove, the temperature of water is 15 degrees Celsius, and after 20 minutes temperature whatever, maybe suppose it's 80 degrees Celsius, and someone asks you what is the temperature increase after that putting on stove, then the formula is what? Final minus initial, that is what? Linear, okay. It's a very simple definition for linear things. Here the uniform and non-uniform linear motion. So here they are giving us a simple easiest demonstration, that is what? Suppose here we are having a track, a wood track, and we are having also a ball to scroll down this ball on this track, okay. The first time we use the top side of that track and release the ball from here, okay, and just calculate the time taken to reach here, okay. And second time we are release ball from the middle of the track and calculate the time taken to reach outside of the track. So in both time the speed of ball will variant. The speed of ball will be variant. Definitely if speed is variant, then definitely time taken is also variant. So tell me why the speed is variant? Time may be, why? Because of the distances vary, so time should be vary, but the speed is vary at both place. Why? What is the reason behind that? Yes?
Because the slope is there, that's why the ball gets the velocity on the top, and in the middle the ball did not get the specific velocity
As compared to top side.
as compared to top side.
Why?
Because because from upward direction, when the object is thrown or
The object is scrolling, huh? Keep in your mind first of all. It's not throwing.
object scroll, then it gets a specific velocity with air, and the object scroll down fastly, and in the middle the object scroll down slowly because it did not get the support of the air, and the velocity does not increases as much as increased in top.
Okay. If we do this demonstration in a vacuum, there is no air. Then, if we do this practical in a vacuum, there is no presence of air. Then
Also same condition, sir, because in the middle it did.
why the difference between the time taken, or why the difference between the velocities are 2 times? For example, are you getting what I am saying you? Okay, if the ball released from the top side here, if you calculate the speed here of that ball reaching time, the speed is what? Suppose 10 km per hour. Okay, for what? For top releasing. Okay, for top releasing point. If I release this ball from here, means middle release point. So here the speed is what? 7 km per hour. Okay, this is what? Middle releasing point. When we release this ball from middle, then at the releasing time the speed is what? 7 km per hour. When we release this ball at the top side, then the releasing speed is what? 10 km per hour at here. Why this 2 times the speed of ball, the velocity of ball is vary? Are you getting my question right now? Then tell me, what is the reason to get varying the speed or varying the velocity? It just because of, yes, acceleration due to gravity. Acceleration due to gravity. The only reason behind that is what? Acceleration due to gravity. When we release ball from here, so after that releasing, balls start to scroll down. Okay, due to this scrolling here, somewhere is the force, gravitation force act on that ball. Okay, after that covered 1 centimeter, suppose 1 centimeter, this ball having its own acceleration. Okay, and still gravitational force put another one acceleration on it. Then the speed will be increase until it reach at the surface of the earth or release point. Okay, now here the distance is very less as compared to this. So that's why here again it accelerates due to gravity, but distance is too short. That's why gravitational force act on it, but it not take enough time to accelerate it at much than the top side. Clear? समझ में आ रहा है? यहाँ पे 2 जो वेलोसिटीज अलग अलग मिल रही है, वो किस लिए मिल रही है? टॉप से अगर रिलीज करोगे उसे तो होगा क्या? ये एक्सेलरेट कर जाएगा ड्यू टू ग्रेविटी, यहाँ पर भी एक्सेलरेट कर जाएगा ड्यू टू ग्रेविटी, लेकिन यहाँ पे उतना स्पेस ही नहीं है ना, उसको स्पेस ही नहीं मिल रहा है उतना एक्सेलरेट होने के लिए. जैसे कि अगर किसी स्पिनर बॉलर को बोला जाए कि आप फास्ट डाल दो, किसी स्पिनर को बोला जाए कि आप फास्ट डाल दो, या फिर किसी फास्टर बॉलर को बोला जाए तो रन भी ना ले और फास्ट डाल, कैसे पॉसिबल है? एक्सेलरेट तो होना पड़ेगा ना बॉडी को. यहाँ पे एक्सेलरेट हो रहा है लेकिन उतना नहीं जितना यहाँ पे एक्सेलरेशन मिल रहा है. ओके, सो वेलोसिटी इज इक्वल्स टू व्हाट? डिस्टेंस अपॉन देन टेल मी एक्सेलरेशन मीन्स व्हाट? यस, एक्सेलरेशन मीन्स व्हाट? Rate of change of velocity, or sometimes we called speed also. Okay, sometimes speed is called a rate of change of velocity or speed. Sorry. With respect to time or a specific time is called what? It's called acceleration. Clear? The next is what? We're talking about what? Final and initial. So before releasing this ball having some velocity, that is what? Initial. Okay. At the time of releasing from the track, the ball having some velocity, that is what? This is Vi and this is what? Vf. This is Vi and this is Vf. If I want to calculate the velocity of that ball, is then Vf minus Vi, which is equal to what? PL, linear velocity. Clear? Okay. So now here we discuss about what? Positive, negative and zero acceleration. Okay. Assume here we are having a car and our car is moving on the road. Okay. So here, suppose here before starting the car, this car having some velocity, this car having some momentum, this car having some displacement. Clear? And the time taken to this thing means at rest. Time is also something, na? So here time may be vary. Time may be vary. It means what? T may be n, 1, 2, 3, 4, 4, whatever, second. Okay, in a second. But velocity is what? At rest. We are talking about what? At rest condition. Before starting, before move. Velocity is what? 0. Momentum is what? 0. Displacement is what? 0. But time should be anything. Means n. It may be 1 second, 2 second or whatever. Okay. But here suppose our car is moving. Our car is moving. Okay. Now at the moving time, suppose velocity is what? 30 kilometer. Velocity is what? 30 kilometer per hour. 30 kilometer per hour. Then momentum is what? Something with respect to that specific time. Then displacement is what? That is again something. That is our area to calculate. And here T means what? That is again something. Okay. Suppose our velocity is constant. Our velocity is constant all over time. Suppose we are traveling up to 100 kilometer. Okay. Here our velocity is same, 30 kilometer per hour. So at that time our acceleration is what?
0.
Our acceleration is what? 0. We are moving in a constant velocity, constant speed. So our acceleration is what? 0. But sudden, if our velocity is increased with 50, now our velocity becomes what? 80 kilometer per hour. It means what? The speed is going to up or increase. It means what? We are dealing with positive acceleration. Positive acceleration. Clear? While our car is running with speed 80 km per hour and sudden the speed becomes what? Suppose 50 km per hour. It means what? Our speed goes to down. This is what? Negative acceleration. Clear? Okay. This is very good example to understand negative, positive and zero acceleration. That is different thing. We are not dealing with here how much distance is covered per minute or per second. We are just here observe what? Positive, negative and zero acceleration when our object or vehicle is moving with uniform, non-uniform or zero speed. Clear? Okay. Okay. So here we are having a graph with two different columns. So we have liberty to choose the x axis and y axis for these two columns. There is no restriction. This column for x axis and this column for y axis. We may choose any one for any axis. Okay. So let's assume here we use second for what? Time for x and here meter for what? Y. So just observe the value of time is what? 0, 10, 20. It means what? Every time it increment with 10. Okay. So 0, then next 10, then 20, 30, 40, 50, 60, 70 and so on as per our requirement. Okay, the next is what? 0, 15, 30, 45, 60. It means we are easily get the increment order is what? Every time it increment with 15. So 0, next 15, then 30, then 45, then 60, then 75. The last is what? 105. Okay. The last value is what? 105. So here again our same logic we are used already in our previous example. That is what? Just pick the one element from x-axis and find its equal coordinate on the y-axis. Suppose here this is our second and this is what? Our meter. Okay. So here 1 centimeter for 10 second. Here with respect to x-axis and on y-axis 1 centimeter take what? 15 meter distance. Okay. So we are representing in 1 centimeter 50 centimeter. Okay. Sorry, 50 meter. So don't get confused meter and centimeter. Okay. So here, so our first coordinate is what? 15 comma 10. So that is what? 15 from y-axis and 10 from x-axis. Okay. This is our first coordinate. We have number of pattern to plot this graph. Means we are having a line graph, bar graph, pie chart graph. Okay, so easiest way is what? Bar graph. Why? Because of it's easy to understand. So this is what? This is the bar graph. Okay, it's showing the increment from 0 to 10 with respect to on x-axis and with respect to y-axis. That is what? 0 to 15. Second is what? So 0 to 0 means what? Here. Okay. Second is what? 10 to 15. Then 30 to 20. This is what? Yes. So there is no need to draw this side again. So we can show like this. Clearly. Or if you want to draw a line graph, then there is no need to draw these lines. You just directly connect them by using a line also. Okay. Next is what? 45 to what?
30.
So this is what? Yes. The next 60. 60 to 40. Next is what? 75. 75 to 50. Next is what? Yes? Okay. 90 and here somewhere is what? 105. Okay. So this is, yes, 90 to 60 and now 105 to 70. Okay, so here we can write here, this is what? 105 comma 75. Here this is what? 90 comma what? 60 and here is what? 45 comma what? 50. 40. 75 comma 50. Okay. Sorry. 75, 19. This is what? 105. Second is what? 60. 60 comma what? 30. And this is what? 45 comma 20. And this is what? 30 comma what? 20. And this is what? 15 comma what? 10. Okay? Clear?
Yes.
And scale is what? On x-axis? Yes. 1 cm is equals to what? 10 second. And y-axis 1 cm is equals to what? 15 meter. Clear? Isn't it? It's very simple. If you observe it before drawing, carefully observe the table, then imagine we are having two axes, x and y. Then you may easily assume or you may easily calculate the numbers which we put every 1 centimeter. Okay.